I go ahead and load code blocks. I guess so that's loading. I can go ahead and start talking. I've left a little bit more in this PowerPoint than what I'm going to cover. I don't think I have time to cover it anyway. But I wanted to leave it in there for some of this good information, and I'm gonna upload the PowerPoint so you can read it yourself. The actual original PowerPoint was 200 slides, so I cleaned that up quite a bit. This is kind of overkill. If you read the book, you'll get the same explanation and so forth for those missing slides. But this is how to work with C functions. We've already done a little bit of this. Objectives. Construct programs modularly from small pieces called functions. Use common math functions in the C standard library. Create new functions. Use the mechanisms that pass information between functions. Learn how the function call return mechanism is supported by the function call stack and stack frames. And use simulation techniques based on random number generation, and write and use functions that call themselves. Modules in C are called functions. We've already been working with the C standard library. Printf, scanf, POW that were used are, as in previous chapters, are all standard library functions. You can write your own functions though, and these are called programmer defined functions. Remember the math library functions we used, like square root. That's already written for you, so you don't have to write it yourself. But in order to use that, we had to have our include statement at the top. So we had our # include math.h when using the functions in the math library. Just to refresh your memory. I got a C program. Here's a C program. Oh, right here. Remember here I have my include at top for include math.h. Then in my program, you see I use the exp. So you can use square root and so forth. So for example, printf percent f/n and then square root of 33. Get rid of that. Guess I'm not really using this stuff either. There we go. And it just shows you gives you square root of 33. So again, that's just where you have to have your include math.h at the top in order to use those functions. And there's a square root. Now notice you can take the results of a function call, because when you call this square root like they're doing right here, it's going to return a value. And so when this runs, it'll go off, it'll do this, return the value here, and then plug it into this %.2f. Here's some common ones: square root, cube root, exponential function, e to the x, log, natural base of log base e. That's a little bit different because in college algebra, remember that was ln if you took college algebra. And then log base 10, which is just logged in college algebra. That's our base 10. So f ABS, absolute value of x, is a floating point number. Ceiling rounds x to the smallest integer, not less than x. So 9.2 goes to 10, and ceiling in negative 9.8 is negative 9. So in other words, it goes to the next integer larger than the number you input. So if you put in 9.7, it still go to 10. And the next integer that's larger than negative 9.8 is negative 9, if you think of the number line. There's a floor, rounds x to largest integer, not greater than x. You see the 9.2 goes to 9, because that's the next integer smaller. Next integer smaller than negative 9.8 is negative 10. We've got our POW, which we talked about, F mod, remainder of x divided by y is a floating point number. I don't think I've ever used that. I'm not sure what that's for. It's 13.657. Well, 13 divided by 2 is probably like 6 something, maybe 5 with those decimals thrown in. So it's not dividing, but it says it's returning the remainder. If I had to guess, guessing that F mod takes 13.657 divided by 2.333, which gives us this value, which is 5. We go to the next integer smaller, so let's say 5. Then if I take my original number, 13.657 minus 5 times 2.333, how bizarre. So it does integer division and returns like the 5, because it goes in there 5 times. Then takes 5, multiplies it times 2.333, and subtracts it from 13.657. I'm not sure when you'd actually ever use that. I've programmed a lot of math programs. I've never used that. But anyway, sine, cosine, tangent, or from trig. Functions allow you to modulize your program. Allows you to logically break it up. And here's how to do a square. So you want to square something. You have to have your function prototype up here at top above your main. So up here above my main, I'm going to have my int square, and then inty. Now, down here after the last curly brace for your main, so next page, they have the actual function. Okay, and return y times y. So then down here, I could print the square of something. Square of 5. Now let's run it, then I'll explain it. 5 squared is 25. Now up here, this is your function prototype. And all this includes is your header information here. The INT tells it what type of data is returned. In this case, I'm telling them we're going to return an integer. This is whatever name you want to call it. Following your standard naming convention, can have start with a number, can have spaces in it, things like that. And then this is what's going to be passed in as a parameter. And this says I'm going to pass in an integer. Down here, the header is same as above. And then it's going to return y times y. So this is a line of code. Now when you call it, see, I've got it embedded in a printf here because this is going to return an integer. Because that's what we said it's going to return. We're going to return an integer. That's why I have %d here. So in the program, when it hits this, it says, okay, square. I know that because up here, my prototype said, hey, I'm going to have this function called square. This is how you use it. So it says, okay, I know this. This was told me up here that I'd have it. So then it comes down here to call the actual program. When it calls this, it passes 5 in to the y. So when it starts, y is automatically equal to 5. And then it goes ahead and does 5 times 5, which is 25, and returns that. And now where it returns it from is where it's called from. So it's called from right here. So when that gets done running, it'll replace that piece that I got highlighted with 25. And then it'll plug that into the printf here. And that's how a function works. Let's say I wanted to write a function to, I think one of the programs you had in the past was to compare two numbers and see which one was larger. So let me come up here, and I'm gonna I'll work with integers, though it could be doubles or whatever. Larger, and I'm gonna pass in two variables, both of them be integers, so num1 and num2. Now notice that they both have int on them. Yeah, you have to put the data type on each one of them. Then down here, I'm going to have the same thing. Now the return is what actually brings back the value to where it's called from. So I'm going to check if num1 is greater than num2. Then I'm going to return num1 because it's the larger. Else, and now this isn't going to handle if they're equal, so that's a different issue. So else return num2. Okay, so then up here, I'm going to call it. And I'll call larger, and then I'll be passing in like 3 and 8. Now let's run this, make sure it works, and I'll explain it. Returns 8. Okay. Again, up here is our function prototype, and passing these two numbers here. And then the actual function is defined down here. The code, we're passing in num1 and num2. So this is just checking to see if num1 is greater than num2. If it is, then I want to return num1 because it's a larger number. Else, then I want to return num2. So when I put two numbers in there that are the same, like 4 and 4, it'll return and say that, or print the large number as 4, which is actually fine. Is there any questions on these so far? Let's say I wanted to program that quadratic formula. I don't require you to know math for programming classes, so I'll give you the formula and I'll talk exactly how we need to do it. The quadratic formula is negative b plus minus square root of b squared minus 4ac all over 2a. Now, as far as I know, C doesn't have the capability to return two values. So I'm going to have two functions, one for the plus version and one for the minus version, because that's a plus or minus. So up here, I'm going to say answer plus. Now I'm going to be passing in A, B, and C. What you have to decide from a programmer standpoint is data types. This is going to return a double, so definitely want to change that. And you have to decide if you want to allow them to enter in decimals here. If you don't want to allow in decimals, if you want it to be like numbers 3, 7, 5, and so forth, then you can leave them as integer. Make it a little bit more robust. I'll pass in doubles. So then down here, I can copy all of this except for the semicolon. And I'll paste it down here. And now I need to calculate my answer. So let me declare a new variable in here. Call it an answer. And answer is going to equal to, whenever you have a fraction with more than a single number on top and bottom, you have parentheses around it. So when I program this in, I had to put parentheses around the top. I had to put parentheses around the bottom because it's more than a single number on top and or bottom. So the beginning parentheses at the top, -1 times b, plus, and then our math dot, well, I don't have to put math. C just allows you to just type square root. And then b squared, so b times b minus 4 times a times c, closing parentheses on the square root, closing parentheses on the top of my fraction, divided by 2a. So beginning parentheses, 2 times a. And then I'm going to return answer. Now I want to copy this for my negative answer, or the one with the minus. We had a plus or minus. I hate how they've hidden a copy. You should just use Control C and Control V, but I try to put that there so for people that don't have those memorized. Negative. And I'm going to copy this bit of code right here. It'll be very similar, except for this will be a minus. And stand up for a second. Sitting too long. Okay, so now I want to get the values from the user. So double A, B, C, and I'm going to say printf input A. Normally, single letters isn't appropriate, but when we're talking about the quadratic formula, A, B, and C is the most appropriate thing you can choose. Percent LF is their floating point. Then plug in A. Printf. Input B. Scanf. %LF. Helps if I put the ampersand there though. Something was missing. I was just sitting there trying to figure out what it was. And printf, input C, scanf, %LF, ampersand C. So then I want to print my answers. Print F, answer 1 equals %.2F, comma, and then I'm going to call my answer plus. And I'll pass in my A, B, and C. In this one, I'll have my answer 2 is equal to %.2F. And I'll call answer negative, A, B, C. Get rid of that. Run it, and then I'll talk about it. Let's see, 1, -5, and 6. So my answer is 3 and 2, which is correct. Okay. Now here, got my prototypes, just defining what's coming ahead. Within this main, I got A, B, and C declared. These names here do not have to match the name down here. So your parameters, arguments, they don't have to match. You can. Sometimes it's easier. I get to doing that so often, people think it has to be matching. So if it's ABC here, this has to be ABC, and that's not true. This would equally work if I said this was parameter A, this is parameter B, and this is parameter C. Comes down here, calls answer plus, and passes in those 3 values we just retrieved up here. And down here, when it calls answer plus, it passes those in for A, B, and C here. And I have an answer declared here, double answer. Now, after that function gets done running, you cannot access that variable anymore. That's declared locally. So local variable. The benefit of a local variable is it does not consume memory throughout your entire program. It's there for while you call your function, and then it ceases to exist after you're done running that function. You notice here I'm using A, B, and C, but let me throw another one under D, and I'll say D is equal to 3. How random is that? If I come down here, and let me put a printf in this. Printf D equals %D / n. Was it a decimal? I don't remember. What was D? D is a double. So let's run that. Gives me an error. And that line has it put in there. Says, let's see, D is undeclared. You might say, well, no, it's not. It's declared right here. These are, again, local variables. And they're local variables, specifically the main. It's our main function, because that's where they're stored at. I cannot access them outside of this function. So down here, if I try to print the value of D, it gives me an error. It says, hey, you can't do that. It's not even declared. Now, I think I can declare them up here. Double E is equal to 7. Now down here, if I try to print the value of E, you notice there's no error. 1, -5, and 6. Get this, and he says E is 7. When you declare a variable up here, this is referred to as a global variable to the entire program. So you can access it anywhere. You can access it in the main function. You can access it in the answer plus function. You can answer it in access, I should say. Access it in the answer negative function. So it doesn't matter where you're at. Global variables are discouraged because they consume memory throughout your entire program. For example, if I'm only using E in this one place, but then I got 1,000 lines of other code, if I declare as a global variable, then it's consuming memory throughout my entire program. The beauty of local variables is use them temporarily, and then give that memory back. Although there's other examples you could go with this. I got local memory for the day. I can remember maybe somebody who I saw this morning. I can remember maybe what shirt I wore. I'm not sure it's a bad example, but I can remember little details. I can remember who I got emails from somewhat, and so forth. Now, that's local to this day. Come tomorrow, and I'm running the next function for tomorrow, I cannot access any of those variables. I won't remember those items. I won't remember who I saw. So it's not quite the same concept, but it's similar to that. Anyway, don't use local global variables. You notice I didn't even know where to put it. You should not use global variables unless you're just forced to. It's kind of poor programming design to use too many of them. Now, I like them because, hey, you don't have to declare. You can use it anywhere. So if I have 10 functions, I can access it in 10 different places without passing it as a parameter or anything. Better way to do it is you declare it here, excuse me, set equal to my 7 or whatever value. And then if I really do need to use it down here, I want to pass it in. So I'm going to pass in double E. So down here, I'll pass in double E. And then there's no problem. Since I have it declared locally right here, I normally can only access it from within main. But I'm passing it. I'm not passing it. Now I'm passing it. I'm passing it in as a parameter. This is retrieving it as a parameter, and then it print the result. And 1, -5, 6. And you see we got our E is equal to 7. Okay, so that's a couple examples of of functions. So let's come back to here. Maximum, I kind of did one of those, except this has 3 numbers, but see maximum, the prototype says it's going to return an integer, and it's going to pass in 3 integers, x, y, and z. Down here, I bring in x, y, and z. And to begin with, since I don't have any of the numbers, my largest one by default is the first number, which is x. Then I check to see if y is greater than max. If it is, then max is equal to y. And I check to see if z is greater than max, and if it is, then max is equal to z, and then I return it. Now they include this in this chapter, the math data types and their conversion specifications, and I want to point this out. Some of you on your, like when you did your printfs for double, and some of you use float and so forth, you're using LF for your printf. Well, the convention on that is for double and float, you always use %f. I didn't take any points off for anything because enough people did it. I'm assuming somewhere in the book they actually used it that way. But the standard is that when you're doing a printf and you're working with double or float, you always use your %f. And here's our other ones, depending on what you're bringing in. And again, I'm not going to read those. I'm going to upload this spreadsheet so you'll have it. Now I'm going to give you the idea of a stack. Now I cut out a lot on this. You can read the book and get a lot of detail on how functions are stored on the stack and so forth. The idea is same as when you go to a Chinese restaurant. I love Chinese food, and they oftentimes have buffets, and there's a stack of plates that they get pushed down, and when you go up, you get a plate off the top, and it pushes it up. That's the idea of a stack. And I give you the example, pushing the dish onto the next stack. When you're working with functions, it does a similar item where it uses the stack to keep track of it. So it knows where it's called from and what to return and so forth. Not a whole lot of detail there that you really understand, but you will get Stack Overflow sometimes. And this occurs, especially with recursion, it's where you call on a function over and over. So calling itself over and over. And it runs out of memory. So Stack Overflow. Okay. See, I'm going to read all that to you. Now, headers. Programmer-defined header can be included by using the #include preprocessor directive. For example, if the prototype for a square function was located in the header square.h, we'd include that header in our program by using the following directive: #include and then square.h inside of quotations. That's the same principle as like math.h. Now here's our common header files, and I'm not going to sit there and read all those to you. But if you're trying to figure out what one does what, this might get you started in the right direction. Okay. Passing arguments by value, by reference. This becomes important with the, do you want to change the value in its storage location, or do you want to change a copy of it? The principle here, by value and by reference, if I'm sitting here in my office and I have a student and I tell them that I want to get this book to the next building. So I ask them, take the book over for me. They take the book over, and then whoever gets it maybe marks up the book, puts writing in it, and that's what I want. Let's say. they're actually changing the true book. Now, instead of and by value and by reference, the by reference means that I'm referring to where the location of the book is. In this case, it's in the student's hands. The pass by value means that I'm making a copy of the book. So first, I have the student write down everything in the book, and then they'll take the copy over to the other building. Now that copy can be changed, but in no way is the original changed. So my original book's over here and hasn't been affected. Now there's ways around that. When you return something, you can have it update your original copy. But that's the idea of the by value and by reference. Now random number generation. This is kind of interesting for programs. This right here is I is equal to rand and then begin parentheses, close parentheses, and this comes from the standard library header. There we go. So I is equal to rand, beginning parentheses, closing parentheses, returns an integer between 0 and rand max. So let's see what in the world that does. Let's see num1. Num1 is equal to rand and printf value of num1 is %b / n num1. Okay, so let's run that. Value of num1 is 41. Run it again. Num41. Oh, what a coincidence. 41 again. Now you may be saying, well, that doesn't seem very random. Gives you the same number. That's on purpose. The idea of the rand is it gives you a random number, but it'll give you the same random numbers unless you do something different. This is useful if you're trying to debug your code and you're trying to see from program run to program run if it's giving you a correct result. Well, it gives you brand new numbers each time, then you have nothing to really check it against. Okay, so that's random number. Now to pick a random number from 1 to 6, this is how you do it. You got your 1, which is starting. So 1 plus, then inside of parentheses, got my rand, %6, close parentheses, close parentheses. Okay, so if I run this, I got something wrong. Too many parentheses, looks like. Oh, that's a printf. Print 6. Run it again. Print 6. Run it again. Print 6. Okay. So we saw the issue, but now it's returning a random number between 1 and 6. Okay. By the way, it won't keep returning it. As you call this over and over, then it'll generate a new one. It's only when you start the program from scratch, we'll always just give you 6 over and over. So for example, if I wanted 5 random numbers, I have a for loop here for int x equals 0, Continue while x is less than 5, x plus plus. So pass that in. 66556. Boy, that just doesn't seem very random to me. How about x is less than 25? So return 25 numbers. That's better. Okay. But this still will always return these same numbers each time I run it. Notice 6655. If I run it again, my top 4 numbers should be 6655. And it is. Okay, so get around it. We use a seed. A seed allows you to plant a random number, a generic random number that will cause the random number generator to come up with different random numbers each time. Yeah. Oh, I think this is it. Excuse me. I didn't sleep very good last night. Okay, here's randomizing a random number generator. You declare unsigned integer seed. There we go. Then you do sran seed. That seed's the random number generator. Now notice where this is done at. It's done up here outside of the for loop. So let's see, here's a for loop. Sran seed. Now if I run it, got something wrong. Unsigned integer spelled out. Run that. No longer my first 4 numbers, 6655, whatever it was. So it varies. So this is how you do true randomness in C. Now here's the part talks about storage classes. I'm not going to go into that, but it kind of refers to scope. And the scope is an important thing to understand. We're talking about local variables and global variables, and those are important ones. These will provide some additional items. I want to get down to recursion because that's kind of bizarre. Your scope rules, again, you can read all that. Okay. Okay, let's talk about scope. Recursion. Sometimes it's necessary to do recursion. For example, if I'm writing a robot spider program that's going to go through somebody's web page like cali.edu, and it's going to go through every page on the site and either index it for a search engine or it's going to harvest the email addresses for spamming purposes. Well, for the first web page, index.html, it perhaps links to 10 other pages. So I then need to go to those 10 pages, see where those link to, and then go to those. So it has to be done recursively. There is no way, because you don't know how many you have. I could have 10 links on index.html. I could have 50. We don't know. So recursion allows you to recursively go through it. It's good for directories too. So if you're writing system utilities, you need to know recursion. If you're wanting to write a spider program of some sort to traverse through a website, then you need recursion. For the most part, you try to avoid recursion if possible. You avoid functions if possible. All of those add additional overhead, especially recursion. You can very easily get a Stack Overflow by doing recursion. I bet I can program a Stack Overflow. Let's see. It's like, why are you wanting to break it? Call me. And by the way, it doesn't have to be an integer, so it doesn't have to return anything. You can put a void, which says just call it and don't return anything. And then down here, I'm gonna void call me. And it's going to call itself. Now, each time it does a call to itself, it puts more information on the stack. So assuming this lets me run this, we'll have a Stack Overflow. So first time it calls call me, it then calls itself. And calls itself, calls itself, calls itself over and over. And in my main program here, I got call me. I can call it. Well, that's disappointing. I was hoping to say Stack Overflow, but that was bombed off. Other programming languages will actually say that it's a Stack Overflow because you exceeded the limits of the memory of the stack as you kept putting the function calls on top of it. So this is the idea. It calls itself over and over. And you said, why would you want to do that? It's like calling yourself on the phone over and over. Well, sometimes it's necessary. They give an example of factorial, which isn't the best example because I can program the factorial a lot easier than using recursion. Okay, so up here we got an unsigned integer I. We're looping through and printing off all the factorials. And I'm calling factorial, passing in I. Let's say I is equal to 5. I come down here, I'm passing in 5 in the number. So it's saying, okay, is number less than equal to 1? No, it isn't. It's 5. It's greater than 1. So that's not true. So it comes down to this else. And then it calls itself. So calls doesn't return, and then number times factorial. This factorial here is calling itself. Now number was 5, so we put 5 in for number. You got 5 minus 1 is 4. So it's calling itself, passing 4 in as the number. Comes down here, still not less than or equal to 1. So it comes down here, calls itself, passing in 4 minus 1, which is 3. Over and over and does this. Now once it is less than or equal to 1 and does a return 1, then it'll start plugging the values here and doing the rest of this statement. If you're real curious about recursion, I'd suggest reading a book on it. It'll go into a lot of detail about what each pass does and so forth. I be honest, I was never very good at recursion. I have a hard time wrapping my mind around something calling itself. I can do simple ones like factorial, but you get anything more complex, and I really have to think long and hard about it. It takes a lot of effort. Not to mention, it consumes a lot of memory sometimes. Because if it's calling itself 500 times, then it's just put that on the stack. So let's see how many times before it blows up. Okay, so printf pass, and I'll do %d/n. And here I'll put in pass count. And pass count is equal to pass count plus 1. Now I can come up here and below my function prototype, and I can declare that pass count set equal to 0. This is declared it globally, so I can use it anywhere. And then down here, I'm increasing it by 1, printing that out. So let's run this again. This is how many times it's calling itself. Placing a lot of this information on the stack. Just hoping it blow up. Grab a drink here. Well, that's disappointing. I'm getting bored watching this. Stack isn't a small item. It takes a while to exceed its limits. But anyway, you get the idea. Here's some more about secure random numbers. C standard library does not provide a secure random number generator. According to the C standard documents description of function rand, there are no guarantees as to the quality of the random sequence provided, and some implementations are known to produce sequences with distressingly non-random lower order bits. The CERT guideline, MSC 30-C, indicates that implementation-specific random number generation functions must be used to ensure that the random numbers produced are not predictable. This is extremely important, for example, in cryptography and other security applications. And in section 510, we introduced the random function for generating pseudorandom numbers. The guideline presents several platform-specific random number generators that are considered to be secure. For example, Microsoft Windows provides the crypt genRandom function, and POSIX-based systems such as Linux provides a random function that produces more secure results. And then they give you more reading you can go off and do. And that's actually the end of that chapter. So just to reemphasize this, you can have void here, which means you don't return anything. There's no return statement. You can have int, which means you return an integer. So like return 1 or something like that. You can have a double. So return double. You could return a character. So on and on, different things you can return. What am I doing there? Let's try it again. I didn't grab a pop before class started. Dragging here. So you can declare it as a character. You can have multiple functions. As you saw with my quadratic formula example, I had 2 of them there. You can have 10. You don't want to just create them for no purpose. If your function has a 1 line of code, unless there's a very good reason why you do that, you normally would not put 1 line of code in a function. The beauty of this is I can call that function in multiple places. So I can call my quadratic formula in 20 different places and not have to recode it each time. Well, that's all I had on that, so I'll go ahead and stop the video and see if you have any questions.